Okay, so we've talked about the markups, we've talked about markdowns. Let's one last little thing about the markdowns before we let that go. Let's say that you have something that has an original price of $70, and it now has a sale price after the markdown of $42. Find the percent markdown. Well, this one isn't near as tough as it looks. To find the percent markdown, all we are looking at is the amount of the markdown, the dollar markdown, over the original price. And we can either just divide it out and move the decimal, or we can look at that as being the percent over 100. So in this case, we have, what is the dollar amount of the markdown here? Well, it's going to be 70 minus 42, which is $28. That's going to be over the original price, which is $70. So what percent will that be? 28 times 100 divided by 70 is going to be 40. So that is a 40% markdown. You can always go back and double check that by taking the original price, $70 times, now 40% markdown would mean we'd multiply by 0.6, 100 minus 40 would be 60, to give us 42. And that is what our sales price is. Okay, so now in the beginning of the class, we talked about the percent markup on cost and percent markup on sale price. For right now, we're going to concentrate on that percent markup on cost. But what happens if not everything sells? We were looking at just marking up a single item based on its cost. But how do we adjust for the fact that some items may not sell? Clothing may go out of style and have to be either sent to the clearance or liquidated. Food products might spoil and not be sold at all. So let's start out with that. Let's look at food products, dealing with a perishable item. So let's say that we're going to bake 400 cookies at a cost of 12 cents each. Let's say we desire an 80% markup on cost. And from experience, we expect that 20% will spoil before sold. Now, that doesn't necessarily mean that they're going to mold or anything like that, but they might dry out and get crispy or just sit there too long that they have to be rotated out. So what we're going to do is we're going to find the required selling price. So this is going to have some extra steps to it. Instead of dealing with the cost per item, we're going to be dealing with the cost for the whole batch, for the whole group. So our first step, step one, is going to be to find the total cost. There's still probably going to be some of those that go bad or something goes wrong. Okay. Sure. So first step is going to be find the total cost. So we have 400 cookies at a cost of 12 cents each, which is going to give us $48 as our total cost. Step two is going to be to do the markup. This is going to work just like what we did in the first hour. So we're going to have our chart. Cost plus markup equals the selling price. Our percents and our dollars. Now we said that this was going to be an 80% markup on cost. So that means the 100% is the cost. The markup is 80%. We just figured out from step one that the cost is $48. Now we can fill in the selling price as $180. The purpose of calculating the markup is to find the total selling price. So what we're finding here really is the amount of the selling price total, not necessarily the dollar amount of the markup. So I can ignore the markup for now. We're going to do 180 times 48 divided by 100. Give us $86.40. So from that batch of cookies, in order to get an 80% markup on cost, we need to get a total of $86.40 out of those cookies. So that part, step 2, is just like what we did before. Now step 3, we've got to account for the perishables. We're going to find the number that are actually sold. So to do that, we first must find how many are spoiling. And then we subtract them. Or we could just do what we were doing with our markdowns and discounts. We could do a complement. What percent here are expected to spoil? 20% spoil, which means 100 minus 20, or 80%, will sell. So we produced 400 times 0.8 gives us 320 cookies that will sell. So in other words, if we did the subtraction, that means 80 of them spoil. 80 of them do not get sold. But they still cost us money. So we have to cover that whole $86.40 with what we charge for the 320 that sell. Now we may sell less than that, we may sell more than that. We're working on average here. So step 4 is to determine the individual selling price. So we already determined that we need to make $86.40 total. We're going to divide that by the 320 that are going to actually sell to get 27 cents for a cookie. So we need to charge 27 cents a cookie. Well, that's up to you. We're just doing the calculations here. Most likely to come up to an even number to make it easier to work with. Let's say that we are going to produce. That's it. Yes.
So why would you go with the 400 to account for the spoiled ones?
We did use the 400 for the cost. We did the cost on all 400.
Okay.
So that's the $48.
Okay.
But we're only going to sell the 320. So we've got to take this. We need to get $86.40 out of them. So we're going to need to squeeze. That's what we need to cover the cost of all 400. So we're only going to use 320. Okay, perfect.
So you're covering the amount that spoil from marking it so that you don't waste money.
Yeah. So let's say we're going to produce 30 pies at a cost of $4 each. We expect 10% to spoil. We need a 60% markup on cost. So step one, again, we're going to look for what's the individual selling price. What's step one? Find the total cost. So here we have 30 pies times $4 each gives us a total cost of $120. What's step two? Use the markup to find the total selling price. So cost plus markup equals selling price. What's going to go in the chart here? Cost is $120, perfect. Markup is 60% on cost. So that tells us 100% goes on the cost, 60% on the markup. 160 for the selling price. And we were looking for the dollar amount of the selling price. So 160 times 120 divided by 100, which is going to give us, is it 192? It's $192. What's step three? Find the number that are actually sold. So out of 30 that are produced, 30 pies produced, what's the percent that spoil? 10%. So that means 90% sell. So we're going to do 30 times 0.9. So 27 pies will sell. So step four, find the individual selling price. So we'll take that $192 that we need for the total selling price, divide it by the 27 that actually sell. $7.11. Or whatever you want to round it to, yes. Any questions? So I have to try one in your notes here. We are going to produce 150 loaves of bread. At a cost of 40 cents each. If you need 120% markup on cost and expect 30% to spoil, find that required selling price. Okay, so step one is to find our total cost. That'll be 150 times 40 cents or $60. Step two is going to be to find that total selling price. Do the markup and find the total selling price. So we have 100% here, 120 is the markup percent, so the selling price is going to be $2.20. Very good. And of course, the cost is $60. We're looking for this, so we can ignore the markup. Cross multiply and divide. 220 times 60 divided by 100 is $132, I believe. Is that what we come up with? Perfect. Step 3, find out how much sells. So we have 150 times, what percent spoils here? 30% spoil. So yes, 100 minus 30 is 70%, so 0.7. So that's going to be 105 that sell. So finally, step 4 is to get that individual selling price, $132, divide by the 105 that sell. $1.26. How many got $1.26? Okay, anybody have questions on where it came from? Okay, well, sometimes the spoilage isn't a total loss. Like when it comes to bread, of course, all of you probably heard of a day-old bakery or something similar to that, where there is like a salvage value basically to that spoiled goods. So let's take a look at an example very similar to this last problem that we did. Let's say that we're going to produce, this time we'll produce 200 loaves of bread. At a cost of 35 cents each. We need 80% markup on cost. We expect 25% spoil. But here's the difference. By spoilage, again, it doesn't necessarily mean it goes bad. Bread is usually sold the next day. If it's not sold the next day, it's considered not fresh anymore. So let's say that we can sell the spoiled loaves for 30 cents each. So now let's find what our required selling price is. Step 1 is still going to be total cost. Stick with me, Cody, okay? Just hold off. So our total cost will be 200 times 0.35 or $70. Step 2 is still going to be to find the total selling price using the markup. So it's markup on cost, 100% goes there, 80% markup. Total cost is $70. We can find the percent for the selling price. 100 plus 80 is 180%. And we're looking for the dollar amount of selling price required. So 180 times 70 divided by 100 is 126, I believe. Is that correct? Okay. So $126 is what we need for our total selling price. Step 3 is still going to be the same. Only in step 3, we need to find the number that are sold and the number that spoil. Well, we have the 200 that we produced. And of course, we said what percent spoil? 25, right? So 100 minus 25 is going to be 75%, or 0.75, which is going to give us 150 sold. Now to find the number that's spoil, we could just take 200 minus that, or we could do the 200 times 0.25, the 25% that's spoil, to get 50 that's spoil. Either way, they better add up to 200 when we're done, right?
Yeah. And if it else,
Now, before we go on to step 4, there's an additional step here between step 3 and 4, which is the recovered cost, if you want to call it that. And in this step, we're going to take the spoiled times the recovery. So we have 50 that spoil times 30 cents each that we were going to get for those, which is going to give us $15. So now when we go on to step 4, which is to find the individual selling price, we first must take the $15 that we recovered from the spoiled items out of the total selling price. So we need $126. We're going to subtract 15 because we've already recovered, or we're going to recover that. So we only need to get $111 out of the ones that we sell fresh. So that $111 is going to be divided by, we sold 150 of them fresh. So divided by 150. $0.74. Now some would say, well, let's just take whatever we sell, whatever we recover from selling the spoiled or expired goods, let's take that as additional profit. And bakery goods probably could just do that. But in some cases, if you're in a tight market, being able to shave that few cents off your price could be the difference between beating your competitor and not. Another example.
so I'm
Yes.
pretty sure getting more efficient than that, the spoiled amount. But then you could have a number of those that spoil.
The number of those that still don't get sold secondary, yeah. And usually there is a tertiary or a third market. A lot of times for baked goods, it's like you're bear baiting. And then it's not sold by the individual loaf or by the dozen cookies or whatever. It's sold by a drum. You'll buy a 55-gallon drum, and you get a certain amount for that. Yeah. Sometimes even less. So let's look at fashion instead of food for a change here. Let's say you're going to purchase 30 shirts, assorted colors or whatever, at a price of $6 each. You expect, once again, 20% to go out of fashion, or out of style before sold. You need, and actually with clothes, that 20% is low. In order to keep a proper stock on the shelves, a lot of times there's a considerable number that's still sitting there when they go out of season or out of style. So a lot of times it's not uncommon to see 35 or 40% that go out of season. Let's say you need to achieve a 50% markup on cost. And again, we're going to add this outdated items or out of style items will be sold on clearance at $4 each. So again, step 1, total cost. 30 shirts times $6 each, it's $180 total. Step 2, we're going to do the markup to find the total selling price. So we have markups on cost, that's 100%, 50% markup. 100 plus 50 means the selling price is 150%. And we have the 180 going in the cost. We want to find the dollar selling price, so I can cross out the markup. So 150 times 180 divided by 100 is going to be $270 that we require from those items. Step 3. Find the number sold and spoil. Obviously, it's not spoiled in this case, but I'm going to keep using that term because it's the shortest way to put it. We have 30 items times 0.8. Where did the 0.8 come from? 100% minus 20%. Means 24 will sell. Or I can do 30 times 0.26. Again, they're not really spoiling, they're just going out of style. Then we have our additional step here, which is our recovery. That's going to be the 6 that go out of style times $4 each. So we're going to recover $24 from those. So step 4, to find that individual selling price, we're going to take our $270. But before we divide it up by the 24 shirts, what are we going to do? We're going to subtract the $24 recovery, get $246. That is going to get divided by the 24 that need to be sold, which is what, $10.25, I believe. Good news. That's it for tonight. There's a new quiz due tomorrow. That is Wednesday at 11:59 p.m. There's new homework that's not due. I'll check the system to make sure. I might have put it down due next Wednesday, but it's not due until 2 weeks from today. So that would be on the 20th. At start of class. And of course, okay, go ahead. And of course, that next class 2 weeks from tonight is test 2. So be ready for that.
And today's date would be?
Today's date is 10/6.
10/6?
Okay, so the computer lab next door is open if you want to get started on a quiz or the homework. Otherwise, have a great week. Yeah, I'll keep that up there for you.